Okay, so let me find a past paper on redox to help the person that asked the question on that. Redox. So let's see if we can. Okay, so are you there? Now, this is the question, the kind of question you are referring to, or you referred to, right? So somebody is saying that they gave you a question like this. How do you quickly tell which is oxidized and which is reduced? Is it this kind of question, right? And you're expected to do it within 1 minute maximum. So just look at this. Say which oxide is oxidized in this reaction? Which oxide is oxidized in this reaction? So quickly, we are checking this, right? Look at this example I gave. Can you see what has happened to this? What has happened to this? It has been reduced. Reduction. You know, Pam, this guy is gone. What has happened to this guy? Can you see? This guy is gone. Can you see that? This is gone. This is gone. Can you see? So I'm looking at this guy. What has happened to it?
It has been oxidized.
Oxidized. What has happened to it? So my answer is what? B. Can you see? So you may think that you want to do oxidation number for all of these. No. I'm not sure the person that asked the question has returned.
I'm here, understand what you're saying.
You get it, right? So yeah, yes, the moment you see, they too, they will know. They won't give you 4 questions where you have to do oxidation number for 4 for just 1 mark. Okay, so easy like this, right? Another thing that you also need to learn is that possibly we didn't tell you in class is we also use hydrogen. Addition of hydrogen is reduction. When hydrogen is added to something, it's reduction. When oxygen is added, is oxidation. When oxygen is removed, is reduction. Removal of oxygen, addition of hydrogen, reduction. Removal of hydrogen, addition of oxygen is oxidation. Do you understand? So you can quickly use that to do it. Do you get it?
Yes, sir. Thank you.
Okay. Yeah.
Sorry, sir, please may you repeat what you said regarding hydrogen?
Yes, I say addition of hydrogen is reduction. When you add hydrogen to a compound is reduction. Okay. Removal of hydrogen is oxidation. Okay. So now this is our last lap. So I need to quickly rush. So I've explained displacement reaction, right? And I've linked it to what? I've linked displacement reaction to redox reaction. Okay. So I will explain quickly competition between metals. So what are the competition we have between metals? Compete with carbon, metals compete with metals for oxygen, and metals compete in ions. I'll repeat, metal can compete with carbon, metal can compete with metals for oxygen, then metals can compete what? In solution. That means in aqueous form. So if you look at this example here, this is a competition between a metal and carbon. And of course, you remember that carbon is higher in reactivity than some metals, right? So if a metal is below carbon in the reactivity series, carbon can displace that metal. So we use this opportunity of carbon to now extract some metals. For example, this could be extraction of lead. If I need lead and I have lead oxide, all I need to do is to take lead oxide and carbon. I'll heat them together in the laboratory. I'll keep heating it in crucible. After a while, carbon dioxide will go away and my lead will be left behind in the crucible. Why? Because carbon will snatch away the oxygen from what? from lead oxide, and carbon will turn to carbon dioxide, while lead will turn to what? Lead oxide will turn to what? Lead. So we can see in this reaction, for example, lead has become what? Reduced, right? While carbon has become what? Oxidized. You can see that. So basically, this reaction is possible because carbon is more reactive than what? Than lead. And so you're going to displace what? Lead from its compound. Okay. So the simple equation for reactivity, simple equation for reactivity is, okay, somebody is asking a question. So I know you may not be able to cover this. However, I think maybe in other classes you will cover this common example of exothermic. Okay. Okay, example of exothermic and endothermic reaction. Okay. I'll just chip in some things under that. Okay. So our carbon is more reactive. So what you have is a more reactive metal, more reactive metal plus what? Least reactive metal compound. Least reactive metal compound will be equals to what? Will form a more, this is general equation, more reactive metal compound plus what? Least what? Reactive metal. So the least reactive metal will be what? Displaced. Can you see that? So this is the general equation you need for displacement reaction. The least reactive metal will be what? Will be displaced, you know, from that. Okay. So, but in this case now, what is acting like a more reactive is what? Is carbon. Can you see that? Carbon. So if I do carbon plus maybe iron oxide, which we are going to use this to do what? Reactivities, what extraction of what? Iron. Can you see? Carbon plus this will give us what? Will give us more reactive metal compound. So we are going to be doing carbon dioxide plus what? Plus iron. So can you see that? So carbon can displace what? Can displace iron from its compound. So we can find a balance this equation. This is 3, 6, 2. So this is 4. This is 3. So we can balance that equation. Okay. So this is competition with carbon. So any metal that is lower than carbon can be extracted from its ore using what we call reduction with carbon. That's the method. So reduction method can be used to extract what? Such a metal. Now we also have other competition. I mean, here you can see iron, two metals now, iron and copper. Iron and copper. They can give you a list of these reactions and ask you which of the reaction is possible and which one is not possible. So what you need quickly is your reactivity series. You know, they told you that you need to know the table from potassium to sodium to calcium, you know, to magnesium. It goes on aluminum, carbon, zinc. It goes on like that until you get to what? Until you get to gold. You have to know it offhand. Okay. So the moment you check it there, you just say, oh, where is iron? Here. Oh, iron is higher than what? Than copper. If iron is higher than copper, then means iron can displace what? Can displace copper from its compound. Right. So it's a displacement wall reaction. And they can ask you to show that this reaction is a what? Is a redox reaction. Can somebody give me the ionic equation for this reaction? Just state it. What's the ionic equation for this reaction? What's the ionic equation? Of course, we are starting with
It's like the half equation.
No, ionic equation. Then we can then do half equation. This ionic equation, yes.
Plus copper 2.
Plus copper 2 plus, yes.
Plus oxygen 2 minus.
Okay, plus oxygen 2 minus, okay.
Iron plus 2 plus.
Iron 2 plus, yes.
Then plus oxygen 2 minus.
Then plus what? Copper, right?
Plus
Yes.
copper.
So like
So we
at the end of this,
you
cancel the oxygen. Brilliant. Then you're left with what? You're left with Fe2 plus, right? Plus what? Cu. So this is what you now use to now write the what? Half equation, right? So what is the half equation? This guy goes to this guy. increase in oxidation number from 0 to what? To +2.
+2.
That is what? Oxidation. So my oxidation half what? Equation is what? Is Fe
Fe minus
Fe2 plus 2E minus, right? If you like, you can write it like this. Fe minus 2E to give you what? Fe2 plus.
Fe2 plus.
Do you understand? It's the same thing. It's just doing mathematics, right?
Yes, yes, sir.
Right? The reduction therefore will be what? Reduction half equation is what? Cu2 plus to what? To Cu.
Cu.
So that means I do Cu2 plus. Before a positive ion becomes a metal, what will happen to it? It must gain electron, right?
Yeah.
To form Cu. Bam. Ta-da. That's it. Can you see that? So they can bring in redox, in all that together. Okay, so the last one I've looked at underneath this is what? Competition in what? Of metals in solution. In solution. So you can see in solution. See, look at this ion. This is iron. If you drop iron into a solution of copper sulfate, the iron will be coated with what? With brown copper. It's a very simple reaction you can even do at home. Right? Iron, if you get copper sulfate, just throw the iron nail if it is made up of iron. Why? This is telling us that copper has been what? Displaced. How do we know copper has been displaced? Because we saw brown copper on the nail. The equation for reaction is simple. So you can see iron is higher than what? Copper in the reactivity series. So what happened? Iron is what? Iron goes A, copper is displaced, where iron wall forms this. So this is a more reactive metal plus a what? A less reactive metal compound will form a what? A more reactive metal compound plus a less reactive metal. Very simple. Very simple. So they can ask you to then take this one and write the ionic equation, then write the redox equation. Very simple. Fe, right, is standing alone. Plus copper sulfate is Cu2 plus what? SO4 what? 2 minus. To give you what? Iron sulfate 2 plus what? SO4 what? 2 minus. Plus what? Copper. This guy cancels this guy. I'm left with what? Fe plus Cu2 plus to give me what? Fe2 plus what? Cu. Can you see that? So this guy, oxidation, why? The other one is what? The other one is reduction. What? Reduction. So if it's reduction, what? So this is my oxidation half cell. Sorry, half equation. This is my reduction half equation. Oxidation is Oxlo-Reduga. Oxlo-Reduga. Or oil rig, if you like. Oil, loss of electron. So Fe minus what? For it to be 2 plus, you must have lost 2 electrons, right? To form what? Fe what? 2 plus. For this guy to have become from 2 plus to what? To 2, to 0, you must have gained what? 2 what? Electron. So form Cu. So here, what is my reducing agent and what my oxidizing agent? What's my reducing agent? Anybody? Yes.
Fe is your reducing.
Fe is a reducing agent. Why? Because it becomes what? Oxidized. Or because it lost what? Electrons. Can you see that? If they ask you to explain in terms of electron transfer, you don't say because it oxidized. You say because it has lost what? Electrons. Are you saying that? So reducing oxidizing agent is what?
Copper 2 plus.
Oxidizing agent is copper sulfate or what? Copper 2 plus. Can you see that? Not copper. Don't say copper. Copper is a product. It can never be. Is what? Copper 2 sulfate, which is the reactant. And since copper ion is inside, so I can say copper 2 sulfate. But the actual thing is what? Is copper ion. Is that taken?
Yes, sir.
Okay. So now, yes, another thing. Hi, oh Jesus. Let me move so fast so that I don't go beyond 6:30. I know you guys have other things to do. Okay. Okay, relative unreactivity of aluminium. Why is aluminium relatively unreactive? Even though aluminium is higher in the reactivity series, right? It can react with oxygen vigorously, but that is when we are using powdered aluminium. Okay, many things that they use aluminium to do, you will notice that they don't paint it. Aluminium railings, aluminium roofing sheet, and stuff like that. They really don't paint it. Anyone that paints aluminium roofing sheet, he just want to show he or she has money. It has no structural reason, because aluminium does not corrode. The reason is because the aluminium forms strong oxide with what? With oxygen. Is Al2O3. It's a very strong bond because the oxide electrostatic force of attraction is between 3 plus and what? O2 minus. Can you see? It's very strong. The charge between them is very strong. So aluminum oxide is very strong. So pure aluminium, okay, when it is exposed to the atmosphere, over time, forms a thin layer of strong aluminium oxide over it. That is why over time, the aluminium will no longer be shiny, but it will not be rusty. It just goes dull a little bit, and it stays like that for years. In fact, it becomes more whitish. I don't know if you have noticed that. It becomes more whitish. Just look at any aluminium railings around. Initially, it could shine like every other metal, but over time, when iron would have gone brown, aluminum will go white because of the oxide of what? White oxide of aluminum, white layer of aluminum oxide over it. That white layer is so strong that it will not wear off. Rain will not wear it off. Wind will not wear it off. Heat will not wear it off. So the upper layer, okay, protect the aluminum inside. So we say the upper protective strong aluminum layer preserve the what? The lower what? The lower aluminum inside. So that's why it then look as if aluminum is unreactive. So if I take a piece of aluminum that has been exposed over time and drop it in acid, okay, it's going to act as if it's less reactive. Why? Because the aluminum inside is not reacting with acid until the acid has weared off the what? The layer of aluminum oxide before the aluminum inside will not have the opportunity to interact with the acid. Do you get that? It's just like somebody who is wearing raincoat. The water is not touching it, right? So it looks as if the person is water resistant, but actually it's not. Do you understand? So this is explaining the relative unreactivity of what? Of aluminium, right? I'm going to jump corrosion of metals. Corrosion of metal. I mean, we've done that since year 9, right? So I want to go to extraction of iron. So let me quickly, I will jump all this. Yes, let me let you guys do this. I'll give you 2 minutes to do five multiple choice questions, 30 seconds. Quickly, put your answer. Just write your answer. Yeah, you can type your answer if you'd like. Yeah, number 1, just say number 1, this, number 2, that, like that. Quickly. 30 seconds for a question, so I can move to extraction of iron, which will be the last thing I'm looking at. Okay. Good. Number 1, what? Yes, put your answer quickly, guys. Number 1. Okay. Number 1, C. Okay, Shemilore, C. Number 1, C, correct. Number 1 is C, correct. Number 1 is C, correct. Yes, more. Yes, more. Number 1 is C. More. Okay, good. Number 2, quickly. 30 seconds is over. Number 2, which property is not considered the typical property of metal? Quickly. Yes, we'll get 2 responses and move on. Number 2, okay, good. Number 2 is B, correct. Yes, number 3. We have a few more minutes to go. Number 3. Yeah, quick. Okay, number three. Number three, somebody says C. Okay, correct. C. Number four. While you do that, I'll put some revision question in the chat room that you can download. I believe it will be helpful for you guys. Make sure you go through all the questions, solve it on your own. I have reinforcement question 1 to 3. I'm putting it in the chat room. You guys can download it. Then I'll go to the last thing to do. Yes. Okay. Number 4, C. Number 4, C. Yes, this is alloy. C. Please, that revision question, make sure you go through them yourself. If you have questions, you can ask teachers in school. Which statement is true of all metals? Number 5. Number 5. Quickly. Good. Daniela, good. Farida, good. Correct. Good. Okay. So let me move on to the last lab. There. Okay. We have CBCCA. Yeah. CCBCA. Extraction of metals. So, and I'm just going to touch this extraction of iron. It seems like the urgent one, right? Okay. Now, so these are the things you are supposed to know under extraction of iron. And it's pretty simple to understand. The first thing you know for extraction of any metal is, number 1, you need to know the name of the ore. I mean, what is the basis of extraction? I think I explained that before. You need to know the basis of extraction, which is what this is saying. Say, describe the ease in obtaining metals from their ores related to the position of the metal in the reactivity series. That's learning outcome 1. The first learning outcome is this, right? Metals that are higher than carbon are extracted by what? Electrolysis. They are extracted by electrolysis. Metals that are lower than carbon in the reactivity series, right, are extracted by what? Reduction with carbon or carbon monoxide. Because both carbon and carbon monoxide are reducing what? Agents. So the metals that are higher than carbon are extracted by what? Electrolysis. And one of them that we are taking is what? Aluminium, which is what? Aluminium oxide. Extraction of aluminium is by electrolysis of what? Of aluminium oxide. Now, among the ones that can be reduced by carbon or carbon monoxide, we are taking what? Iron, right? That's what led us to extraction of what? Extraction of iron. Okay? All the first learning outcome is taken. So you can see this. Now, describe the extraction of iron from hematite in the blast furnace. Limited to, so these are the things they want us to look at, right? So in the extraction of what? Of iron, pretty simple. This is the way to break it down. What's the first thing to know? You need to know the name of the ore. Name of the ore. What is the ore of iron? Hematite. What is the chemical formula? Is iron 3 what? Oxide. Right? Number 2, you need to know what are the raw materials. Raw materials. The raw materials are what? Coke, calcium carbonate, and what? Iron 3 what? Oxide, hematite itself. Then the third thing you need to know, you need to now know the processes, which include the what? The reactions that take place. Right? Good. So what are the processes you have there? The first thing that happens is that the coke, which is the carbon, right, will react with the hot air. They blast in hot air in here. Hot air in 2 places. You need to know this diagram, because they can draw this diagram in multiple choice and ask to label. So hot air goes in at the base of the furnace. Hot air goes in. That hot air reacts with what? With carbon dioxide to form with oxygen to form carbon what? Carbon dioxide. Then the carbon dioxide further react with more coke to form what? To form carbon monoxide. Now this carbon monoxide is the reducing agent we need in the extraction of what? Iron. Is the main what? Reducing what? Agent. The main reducing agent. So your carbon monoxide then goes in to reduce your what? Your hematite, which is iron 3 oxide, to form what? ion plus carbon what? Dioxide. Very simple. We can balance this equation on. This is 2. If I put 2 here, okay, 3, 6. Balance this. We put 2 here, right? Yeah, 3 and what? And 4. So you can see it's balanced. This is balanced. So this is the equation. Can you see that? So our ion has been produced. The ion produced will then be what? Be tapped off. Will be tapped off. It goes to the bottom. Bottom. That's where the ion will be what? It is called, it is molten. Molten what? Molten ion. That will be tapped off there. Right? Good. We have produced our ion. Then another thing is you need to know is the remover of what? Impurities. How do we remove the impurities in the extraction of iron? We make use of what? We make use of the limestone. But the limestone itself cannot do that except it breaks down first. So your limestone will first will break down. I'm looking at that 4A now. Limestone will break down to what? To calcium oxide and what? Carbon dioxide. Then the calcium oxide then remove every acidic impurity, exemplified by what? Silica. This is called silica or silicon oxide. Or silicon what? Silicon dioxide. Okay, so this react together to form calcium what? Silicate. This is called calcium silicate. The calcium silicate is popularly known as what? Slag. And that slag is less dense than what? Iron. So it is formed just above what? Just above the what? The iron, where it is tapped off. So they can then ask you, what is the uses of the slag? What is the uses of the slag? The slag can be used for what? For building. Can be used for building, can be used for road construction. Okay, is used as plasma of Paris, POP. That's called POP, plasma of Paris. Yes, Toby Babalola, I want to ask a question. Toby, want to ask a question? Or?
So, like, how does the limestone or like the calcium silicate, how does it purify?
Okay, fantastic. Fantastic. You know, this silica impurity is an acidic oxide. It's an acidic oxide. So that makes sense where you are using a base to what? To remove, because this is what? This is a base. So you can see it's a reaction between a base and what? And what? And something that is acid to form what? To form a salt.
Okay.
Do you understand? So it removes silica impurity, and not only silica impurity, every other acidic impurity. It could be sulfur dioxide that is there, sulfur trioxide that is there, phosphorus oxide, all the acidic impurity. Calcium oxide can remove them. Okay, so we use silicon dioxide as an example. Okay, because it's largely present there, because silicon dioxide is sand. Okay, and because they mine it from the ground, you expect that to what? To be present there. Okay.
Okay.
Yeah, so that is extraction of iron. And another thing they ask you, waste gas. They'll ask you, what are the waste gases in the extraction of iron? What are the waste gases? Carbon dioxide? Yes, carbon monoxide, and sometimes nitrogen. Waste gases. But the chief waste gas there is carbon dioxide. Don't forget that carbon monoxide is used as reducing agents there, right? Okay, so carbon dioxide, and of course nitrogen. Nitrogen is present in air. Okay, if they blast in oxygen, they are blasting in hot air. Hot air, they say. And air is a mixture of gases. We contain oxygen and what? Nitrogen. 28% and what? 78% and 21%. So if carbon monoxide took away the oxygen, where do you think the nitrogen will go? It will rise here and goes out as waste gas. Okay? Yeah, that's extraction of iron. Any question? Any question? So I have sent you guys reinforcement questions that will test what you have learned. You can see this is a past paper. Okay, we have 10 minutes to go. So let's just treat this paper. Right? Yeah. So here, look at this question. Can you see the label? What do you think Y will be? Is it a multiple choice question? Oh, it's theory. So what is Y? What will come out of Y? What will come out of Y?
Molten slag.
Eh?
Slag.
No, this is slag. You know, I told you that slag is less dense, right?
Yes, sir. Which one is slag?
Slag,
Okay.
yes, slag is less dense. This is iron, molten iron.
Can we see the options?
No, I was the one just asking. No, but
Okay.
okay, easier. Can you see what enters the blast furnace at X? What enters?
CaCO3.
Hot air. Hot air. Oxygen. The blast. Don't forget the blast in air. Where is that diagram? Can you see the blasting what? Hot air. You need to learn this diagram. If I were you, I would take A4 paper and be drawing it. Stick it to your bed, to your bedroom, everywhere. Stick it. Draw it. Eh? See, hot air goes in, right? If it's multiple choice, if you don't see hot air, you see oxygen. Choose oxygen. Goes in there. Can you see your iron comes out at the bottom? Then slag is above iron because it's less dense than what? Less dense than what? Than iron. You didn't see the past paper. Maybe you logged out there that time. Okay, I will repost it or I post it on Google Classroom. But let me post it here. Those who are not here, that's their shawarma. Okay, I will reposted it. So it's coming. You will see it now. Anybody that logged out will not see it. So it's there now. Okay, so let's go back to the question quickly. I have 8 more minutes. Okay, so yeah, then what leaves the blast furnace at Y? Molten iron. Can you see that? Yeah, don't just write iron because depending on the math scheme, you know, the iron is correct, but it's molten iron. Okay, so let's answer the question. Which reaction is used to increase the temperature inside the furnace? Fantastic. I didn't mention this. Which reaction is used to increase the temperature inside the furnace? Farida, this is one of the things you were asking. The answer is A. Why? Because it's an exothermic reaction. How do I know it's an exothermic reaction? Because it's a combustion reaction. Can you see that? It's a combustion reaction. So yes, you don't need to memorize all, but you need to just know clue. All combustion reactions are exothermic reaction, burning of paper. Do you understand? Neutralization reaction is exothermic reaction. Reaction of acid and base is exothermic. Do you understand? When I react acid and a base together, if I touch the test tube, it will be warmer. Do you get that? Yes. So largely reactions of acid and base are exothermic. Combustion reactions are what? Exothermic, right? Displacement reactions are exothermic reactions. Okay, commonly displacement reaction are exothermic reaction. So these are ways to know, right? So this is the reaction that will release, that will help to increase the heat in the furnace. A. Which reaction is an example of thermal decomposition? Yes, anybody? This is cheap.
B.
B. All decomposition reactions are endothermic. Those are the clues that you need. Endo is an endothermic. That's why it's thermal decomposition, because you need to absorb what? Heat energy. Are you gaining? So the answer is B, endo, decomposition. In which reaction is carbon both oxidized and reduced? In which reaction is carbon both oxidized and what? Reduced?
D.
D. Yes, it's called a disproportionation reaction. Right? Yes, it's a reaction in which a species is both oxidized and what? Reduced. Right? Because you can see carbon here. What is the oxidation number of carbon in carbon dioxide? +4, right? What's the oxidation number of carbon in carbon monoxide? +2. What's the oxidation number of carbon in carbon? 0. That's why we call carbon dioxide carbon 4 oxide. Carbon monoxide is carbon 2 oxide. Can you see that? So that means that carbon 4, it moves from +4 to what? To 0, and also move to what? +2. It is both oxidized and what? Reduced. Can Can you see that? The answer is what? Is it C? No, D. In which reaction show the removal of impurity from the iron? Come on, which one is this?
So it's E.
Eh?
It's E.
E. Removal of impurity.
E.
C.
C.
C for cat. Which reaction? And this one, don't come and say, after all, the last one is E, must be E. No, you have to read it too, because you can choose something more than once. Which equation shows the reaction of an acidic substance with a basic substance? You know, was it Toby that was asking why the other time, right?
Yes, sir.
So, which equation?
C.
Eh? Acidic
C.
is C. Is C. Can you see?
Mhm.
I didn't even know that the answer will not be E. Can you see? Don't go and put E and say mini mani mo. You have chosen
Wait,
it.
sir,
So
sorry.
yes,
Silicon oxide, is it basic or acidic?
it's acidic.
Okay, and calcium oxide is basic.
It's basic. So it's almost like a neutralization reaction,
Okay, sir.
right? Okay. So I think that is how far I could take you guys. Yes, but that's the question I wanted to do a quick check, and we have done that. Okay, so I wish you guys best of luck. I think in school,
The file is not in the chat.
okay, I'll put it on Google Classroom then for you guys. So some of you have seen it, right?
Yes, sir.
Maybe you were logged out. Let me put it quickly now. Let me put it.
I'm still not seeing the stuff in the chat.
Okay, let me put it again. Okay, so what we are left with will be practical, right? Practicals. Okay, practicals, and we're going to do some practical, maybe 2 classes. Monday is gone already. So 2 classes for practical this week. Then you guys should revise periodic table. Okay, periodic table, because work of week term 1, term 2 will come out. Periodic table, yeah, I will send this slide. This slide, I will send it. And I will also upload the videos, maybe so that anybody that wants to replay can replay. Yeah.
So like I can't see the past papers are not in the charts, and I'm not
I
I'm not
posted
logged
it.
out.
Okay.
Please, can you post on Google Classroom?
I'll post on Google Classroom so that many of you can see. I'll post on Google Classroom with this slide. You will see
Thank
it,
you, sir.
reinforcement lesson material.
Thank you, sir.
So you can download from there. So this is my Children's Day gift for you guys. Happy Children's Day.
Same to you,
Thank
sir.
you, sir.
Thank you
Thank
so
you,
much,
sir. Bye-bye.
Bye-bye.
Yes, yes,
Same
yes.
to you, sir. Bye bye.
Bye-bye.
Thank you, sir.
Bye-bye.
Thank you.
Yeah.
Good evening, Mr. Oguntoye. This is Elizabeth, Daniela's sister.
Hey, my queen. How are you?
Fine, thank you, sir.
Wow.